All right, guys, so now we are going to talk about the section 2.2. Section 2.2, and it will be about page 63. Page 63. In this section 2.2, it's all about triangles. And it's very important for you to be able to recognize all these different triangles, whether it's and everything connected to the triangles, like median, angle, bisector, centroid, altitude, base. And obviously, what's connected with a triangle, one of the famous triangles is a right triangle, and with the right triangle goes the Pythagorean Theorem. So we are all going to work with these different triangles. So let's try to do this different problem. So let's try to do the problem number 6, first of all. So in the problem number 6, it's about trying to look at the figure 2.40, which is the B. And basically, what do we have? We have a right triangle. We know that the angle right here is 48 degrees, and we know right there the angle is 90 degrees. And the question is find the angle A. So the angle A is right here, and we need to look for this angle. All right? So in every right triangle, what we are going to say is the sum of the three angles is equal to 180 degrees. So I'm going to say that 180 degrees is equal to 48 plus 90 plus the angle A. And so A is going to be equal to 180 minus 48 minus 90, which is 180 minus 138, and that gives me 42 degrees. I could do exactly the same thing for the problem number 5. Let's try to do problem number 5. Problem number 5 is not a right triangle, so we don't have a right triangle on problem number 5. We have A, C, and B right here, with B equal 40 degrees and C equal 84 degrees. So again, the sum of the three angles, 40 degrees, 84 degrees, and the angle A equal 180 degrees. So A is going to be equal to 180 degrees minus 124 degrees, and it will be equal to 56 degrees. Let's jump to the problem number 11 now. On this problem number 11, we have a triangle, and we know the side, how long is each side, 239 degrees, 239 centimeter, 322 centimeter, and 415 centimeter. And the question is, find the area of the triangle. All right, so to find the area, what I need to know is the formula, which is the square root of S times S minus one side times S minus the other side times S minus the last side. So I need to find S, and S is equal to 1/2 of the perimeter A plus B plus C. So in that case, S is going to be equal to 1/2 of 239 plus 322 plus 415. And S is equal to 488. Now I know S, I can calculate A as equal to the square root of 488 times 488 minus 239 times 488 minus 322 times 488 minus 415. And I'm going to do the calculation for you. And so now the answer is 38,300. My apology, 38,372.9, so almost 73 square centimeters. All right, so let's move on the next problem. And on this next problem, I want to do problem number 9. On this problem number 9, I think it's interesting. What do we have is we have a triangle. We have the height, which is 2.2 feet. And we have the side, which is 6.3 feet. And the question is find the area. So when I have the base and the height, what I want to do is I want to use the formula A equal 1/2 of the base multiplied by the height, which is in that case 1/2 of 2.2 multiply, or 6. For the base it would be 6.3 first, multiplied by 2.2, even if at the end it doesn't change anything. And for the problem number 9, I end up to have a 6.9 square feet. Okay, so now let's move on to do another problem, trying to go over every single thing that you have to do in these sections, which is all about triangle. And I'm going to give you the problem number, let's see, why not problem number 21? So in this problem number 21, find the third side of the right triangle shown in a figure. So you have a right triangle, and you have A this side, C this side, and B this side. You have a right triangle right here, and they're asking you to find the first side of the right triangle shown for the given formula. So you have, in that case, they are giving you A equal 3 inches, and B equal 4 inches, and the question is find C. So how are you going to find C? Well, to find C, I'm going to use the Pythagorean Theorem, which said that the square of your hypotenuse, which is the longest side, is equal to the sum of the square of the two other sides, which is in that case A squared plus B squared. So that means C will be equal to the square root of E squared plus B squared. And if I substitute the value of AB inside this formula, this expression, I will have C equal the square root of 3 squared. Why did I put 9? 3 squared plus 4 squared. C equal the square root of 9 plus 16, which is the square root of 25, and I end up to have 5. Okay, so let's try to work now another problem, and let's try to work the problem number 27. All right, so in this problem number 27, what are we looking for? We are looking for use a right triangle. So we have a right triangle again. We have a right triangle again. This is the side C. We know the angle 23 degree right here. We know there is a 90 degree. We call that B. So by the way, even before to go further than that, what I can right away is look for the angle B, because 27 is the angle B. So I'm going to say that 180 degree is equal to 90 plus 23 plus the angle B. And so my angle B will be equal to 180 minus 113 degree, which is the sum of 90 plus 23. And so the angle B is going to be equal to 67 degree. Let's try to find now for the same triangle 28, and let's try to find the side C. So I know there is a 38.4 centimeter for that side and a 90.5 centimeter for that side. So if I'm calling, if that is B, let's call that A and let's call that C by example, or actually let's call that let's call that A and let's call that C. By using the Pythagorean theorem, I know that AC squared plus AB squared equal BC squared. So I'm looking for BC squared because BC is defined as the side C. So C squared equal to 90 38.5 square plus 38.4 square, and so C will be the square root of 90.5 square plus 38.4 square. And the answer for problem number 28 on this chapter 2.2 is 98.3. All right, so I could try to do another problem, and let's try to do the problem number, just for fun. Let's see which one I'm going to do. I am going to do the problem number 45. So let's try to do the problem number 45. So in this problem number 45, we have a tree represented by A, B, C, because they are telling you if, let's call C the top of your tree, the top of a tree break in B, but still connected, and touch the ground 8 feet from the vertical part of the tree, which is defined by AB. And the question is try to find AB. Okay, it's try to find the height of your tree that is still up. So you have an 18-foot tall tree, and so AB plus BC is equal 18 foot, and you know that AC is also equal to 8 foot. Now, you might also realize, first of all, that you have a right triangle. So you could say, hey, I could use the Pythagorean Theorem. I don't know if that is a good idea or not, but again, what I'm looking for is for AB. So obviously, when I look at my equation right here, I have two variables. Not only I have AB, but I have also AC. So I must find a way to find BC if I want to be able to find AB. So if I was using the Pythagorean Theorem to this triangle, I know that AB square plus AC square is equal to BC square. So I'm able to realize that I have now two equations with two variables. Again, AC is 8 foot, so definitely this equation can be written as a AB square plus 8 square equal BC square. So if I have two equations, two variables, I can, from the first equation, AB plus BC equal 18, express BC as 18 minus AB. And then I am going to substitute BC inside this equation right here. And so I'm end up to have AB square plus 8 square, so which is going to be 64, equal BC square, so equal 18 minus AB square. I'd like to remind you that A minus B square, it's A square minus 2AB plus B square. So I end up to have basically AB square plus 64 equal 18 square minus 36 times AB corresponding to 2 times AB, 2 times 18, 36 times AB, plus AB square. Now, obviously, if I'm looking for AB, I'm going to try to move all the AB on one side and all the non-variable on the other side. So that gives me a AB square. So I'm going to move this AB square, so subtract AB square on this side to move this AB square on the other side. And I like that. And I can also subtract 18 square. What is 18 square? So let's see what is 18 square. 18 square is 324. So I'm going to subtract by 324 right here and subtract by 324 right there. AB cancel out. AB square cancel out. Fantastic, because now I got 64 minus 324 equal negative 36 AB. And if I'm looking for AB, I am going to divide by negative 36, and I will divide everything by negative 36. And when you are looking at the division, you end up to have a positive value of AB equal to 7.2 meters if